Please welcome for the first session, Stop Mocking, Start Testing, Augie Fackler and Nathaniel Minista.
Hi. Thank you. Good morning. This is my friend Augie. He's a contributor to Mercurial and a few other Python libraries.
This is my friend Nathaniel. He's a contributor to Pylint, and we both work on this little site you might have heard of, project hosting on Google Code.
Who's heard of it? Good. Who's a user?
Good.
All right, we're happy to have you.
So project hosting's been around serving bits since July of 2006, so it's about 5.5 years old, plus probably 9 months of development before that. It's got all the things you'd expect in a project hosting website, and we've got about 50 engineer years in the product at this point.
And the median engineer service tenure on the project is just about 2 years. So it's a project that people rotate onto and rotate off of.
Which is not unusual for Google, but it might be unusual for other teams. We have a lot of components. We offer all three of these version control systems. We have an issue tracker. We have a download service for your tarballs. We have a wiki. We have offline batch processing for stuff we don't want to do during request response.
We started off with a few languages. We added a few more. We're currently at least 8 languages that the site is actually written in. People host all kinds of languages with us, but we've actually got 8 languages in the implementation of the site.
We've got a lot of servers and processes, and requests come in through the box at the top of the chart, which is the public series of tubes, and they go to various front ends that we have, either the Mercurial front end, the actual issue tracker front end, etc. And then these other ovals that you see further down are different components, and those might be libraries linked into a front end, or they may be some other RPC service that we talk to. And then at the bottom you see the triangles, and those would be the persistent services that actually store the data. This is not actually what project hosting looks like. This is just a dummy diagram so we can all be on the same page about what the architecture looks like.
So we posit that your service or any other modern scalable web service looks like this, where these ovular components are stateless on a per request basis, and request state is managed in little message types that are sent along the edges, and responses are returned along the same or different paths. And that user data is stored persistently in things like disks or databases at the very bottom.
And so now that you've got a high-level idea of what project hosting looks like architecturally, we'll go through the evolution of the testing practices as the team went through different people, and talk about how we've converged on something for testing this kind of a system that we find to be very compelling.
So we launched in 2006, and we didn't really have a whole lot of tests. We had inherited a test suite from the Subversion source control system, and we were able to run that against our implementation of Subversion, but we didn't really have any other test coverage. And what we had was it had to be run manually.
And on top of that, you had to run it against a pre-configured development environment. So you had to put certain, say, downloads into a project with a certain name, and then you'd run it, and you'd have to manually inspect the output of the script. So it would print, the next line should say foo, and then it would print what it got from the server, and you'd have to verify that that was actually foo. And
so this would take all afternoon.
At least. Yeah. And so things got kind of lax.
It didn't always get done. So we were on a weekly release cycle, and we'd have regressions more often than not. And our users would helpfully tell us what those regressions were on our mailing list.
Which is it's a very effective way to find bugs, but it's also a very stressful way to find bugs.
So some simple lessons from this Paleolithic time period. Your users are not a test infrastructure. If you've given yourself a pat on the back because you've coded a test, but running that test takes more of your time than processor time, you don't get credit. That's not a real test. And a growing project just simply can't go on like this. When you're in that early growth stage of your project, you're probably adding features proportional to the total time of development on the project. Your feature surface area grows linearly. because you're not being burdened with maintenance or those sorts of things. And if you're on a regular release cycle like weekly, and you want to test your entire feature surface area with every release, how much time are you going to spend testing in aggregate? This is interactive. Sorry? I'm hearing quadratic. Right. Well, we weren't quadratic.
We don't have quadratic people working on the team.
Right. So things just came to stop. We got overwhelmed.
So in about 2009, pretty much all of the original team members had rolled off onto new projects. And a second wave of engineers really started taking the project on and making it their own. But this meant that almost all of the people working on the team had no idea how anything actually worked. There were a few components that you maybe have touched, but fundamentally you don't understand the guts of this system. So they required tests for new code, because it was the only way to make things workable. And they required tests for any code that they modified. So you go back, add tests for anything that you're updating. You change some bit of functionality, make sure the old stuff and the new stuff all work. But they snatched defeat from the jaws of victory and didn't write any new tests for code that remained untouched. And superficially that sounds okay, because if you're not touching a piece of code, it can't break. But it turns out that those core persistence things, or the libraries immediately above them, tend to get touched an awful lot. You're going to add an attribute to a project or something, and a method signature changes. And now your untested bit of, say, the issue tracker or the wiki breaks, and you find out when you try and deploy because you have no tests that exercise that against your persistence layer.
Another key takeaway from this time period was we got our continuous build. That's it right there. It sits on top of one of our engineer cubicles. It's green most of the time. When it goes red, almost the whole team knows. It turns out 3 engineers on our team had red-green color blindness, and we had to spend a long time finding just the right green.
Had to iterate on those red and greens quite a bit, and that's actually white to me, which is great.
So we thought we were doing really well. We thought we were on the mend. We thought we were having really good habits.
And even adding tests was helping, but these are actually problem tests that we're writing. And at first they looked really useful because they were preventing bugs, but everyone was making their own mock objects. And what happens when everyone makes their own mock objects is now you have n, where n is the number of tests you've written, stupid little implementations of something that you have to mock out. So when you change that thing's behavior, you have to go find all of them. And this is a trivial little example, right? You have this real object on the top that defines a method that takes 1 required parameter and 2 optional keyword arguments. And then one of the mocks doesn't even accept one of them as a keyword argument, and the other mock doesn't even accept the keyword arguments at all. And this is not going to work because if you swapped those 2 mocks around, the tests would both break. And if you change the method signature of nlolcat and then you start using that functionality where one of these tests is called, you're going to break something and you may not notice. Or if you take away words, right, the user of fake1 won't ever notice that it's gone.
But it wasn't just having proliferation. It wasn't just having n mocks of a given interface that were giving us problems. Even when we had 1 mock, the mock would tell us what we wanted to hear. And it would tell us what we wanted to hear because we told it what to tell us. It wouldn't necessarily tell us anything true to the behavior as specified in the interface that we were mocking. And so we'd run our tests only against mock objects, and then we'd deploy to continuous integration or quality assurance, and things would break because we'd be hitting real objects that had changed slightly in ways that we weren't able to keep track of and keep updating. Python doesn't do any checking, right, because it's dynamically typed. It doesn't do any checking that 2 classes implement the same interface. And nobody else does either.
And you can say, we do code review at Google. You can say that, oh, well, part of your code review process is go check for mocks and make sure they get updated. This doesn't work. We tried.
It didn't work for us. So the lessons from this time period, you should share your mocks. Absolutely share your mocks. I had been given some bad advice a few years back about how you should write separate mocks for every test. We don't believe that. We don't subscribe to that. We reject that. You don't even necessarily have to mock every interface that's used. We believe that if an object type is very cheap, if it's just a stack allocation, a few storage elements, it's not anything expensive.
A data container that doesn't have any behavior.
You shouldn't be mocking it at all. You should never mock a tuple or, and we've seen this. And if you need a mock, you should have exactly one well-tested mock. And by well-tested, we mean you write your test to the interface of what the mock object is mocking, and you run that test against both the mock object and the real implementation, and confirm that both have the same behavior, and that's the behavior that's specified in the interface.
And I actually found a bug in the Bigtable library at Google at one point this way, because the mock had the behavior I expected, and I found a regression because the mock I was using didn't have the bug, and I was able to go back and find a regression that was breaking one of our components.
Now, another thing is that if you don't necessarily have the resources, the time available to write this full test of this interface, there's a really, really cheap thing you can do to get a lot of the way there, which is to use linguistic reflection to just very cheaply check that the interface of your mock object is a superset of the interface of the real object being mocked, or the interface is specified. So that's that all the methods have the same signature, the same parameters.
Yeah, so you'd use the inspect module in Python, and you'd loop over all of the public attributes that exist on both classes and make sure that they take all the same arguments in the same order, and you just check that by looking at the name. Inspect actually isn't that scary. We have a test that does this, and it's bailed us out more times than I can count at this point.
Yeah. Me personally, 5 times at least. So about 2010 or so, we really felt we had unit testing fully in hand. It was going well. And our units were separate, they were isolated, and we felt like there was still a need for something beyond unit testing.
Yeah, so to expand beyond unit tests, we decided to use full system tests to make up for gaps in the unit level coverage. So what we mean by this is, in particular, we were using Selenium to remote control a browser and click through parts of the site that had terrible unit test coverage, because that was better than nothing. But these tests were very frustrating to work with. If you've ever used Selenium, it's a lot slower than a unit test. The diagnostics are often terrible. In our case, we didn't know Selenium very well, so we also had very flaky tests that just had race conditions everywhere. But even when the test did fail for a reason, it would be something like, the server returned to 500. And that's great, the server returned to 500. Now you get to go look and figure out which of the 20 tracebacks in the server's log is related to your test run versus somebody else doing a test or just a different test from this run. It was very frustrating. So we rapidly reached the conclusion that these full system tests just can't be a replacement for the unit tests. They don't help you deal with day-to-day development. We broke them a lot, and it's just a mess. The unit tests provide much clearer feedback, and the other thing we started doing was to test stories with the full system tests. So we didn't.
And this worked much better.
Yeah, we didn't stop writing the full system tests. We started testing, in Agile terminology, a user story. A user goes to the issue tracker, he clicks new issue, makes an issue, another user comes in, triages the issue, the user gets emailed. That's great. Don't try and check your corner cases. We were at one point trying to check cross-site scripting attacks using Selenium, and that gets really slow because you're checking all the different boxes that you could fill in and checking to see where things are leaking through. And it was just too slow, and you just won't live long enough if you're trying to check all your edge cases that way.
So all this was going on, and we were gradually becoming converted. I had been a heretic. I had been fully won over. Our whole team had gone through this enlightenment, and now we've come to the modern era, and we believe we have the right mocking, the right testing, and the right design. So let's talk about our modern mocking, our mocking today. We have a collection of mocks that is authoritative, which means there's a known place for all the mocks. If you need a mock of something, you go look for it there. And if it's there, you use it. You don't write your own in your own little one-off test, way off in the corner. And if it's not there, you can fill it in there.
And we also can statically verify that these aren't included in our deployed binaries. So there's no way that when we deploy, we're going to accidentally be writing to, say, an in-memory data store and catch it later.
Our collection is narrow. It only mocks the things that are actually expensive and that we don't actually want to have present in the test. So things like the network, things like disk, things like partner Google services with foreign code bases that we reach out to with remote procedure calls in production. Our collection of mocks is isolated. There's no code dependency between our mocks and the things that they're mocking. We had previously had mock objects inherit in an object inheritance relationship from the real implementations that they were underlying, and this raised all kinds of problems with method callbacks and reentrance, and a method would change slightly, and instead of getting a not implemented problem, we'd go off and we'd hit some real method and go reach out for a database that didn't exist. We've come to believe that things are much, much simpler and safer and more straightforward if you have no code dependency between your mocks and the real implementations that they're mocking. So if you're in a compiled language, you can compile your mock package without the real things being mocked anywhere in the compile path. We think that's great. And when we say mocks, we've come to believe very strongly in what are technically called fakes. There's a bunch of different types of things out there. There's stubs, dummies, mocks, fakes, and...
We're missing one on it. Doubles.
Doubles. We haven't found that really, really tough terminology all that helpful, but we have settled on what are technically called fakes. So
they even live in a mocks.py module. That's how loosely we use the terminology. It's just not helpful.
But they are full in-memory implementations of the interface that they are mocking, and they're not the kind of mocks that can be scripted. They're not the kind of mocks that you say, well, assert that this other method is called 4 times and then return value y. We still have those types of assertions in our tests, but they have to be extrinsic to our mocks, and we're better off for it. So going back to this example of a modern scalable web service, what is it that we're mocking? It's all those expensive things, those expensive stores, and those remote services that are represented at the triangles at the bottom. We don't have mocks of any of our own core business logic as represented in the middle of the diagram, and we don't have mocks of any of the message types that represent user request data and user response data that are passed along. Those are stateless, or they're simple, or they're otherwise inexpensive, and so we don't mock them. We've changed our testing around a little bit. You've probably heard that you should write your tests to an interface and not an implementation. We said it earlier, but you've certainly heard it before. We really, really, really believe this, to the point that when we're writing a test, we'll often ask ourselves, how flexibly could the implementation under test change without our having to change the test that we've just written? And we feel really good when the answer is 0.
And this has been valuable because, like the example I mentioned before, we had a test that was passing against a mock bigtable and failing against the real thing, and we caught a very esoteric feature regression because of that. And the upstream team was actually really glad for that. Right? We found something before it got out into the wild. But this is also valuable when you're doing your system tests. Our system tests actually run both in our continuous integration environment and against our quality assurance instance of project hosting that's actually standing up with everything, and it runs week in, week out. And you could use it, but we wipe it occasionally. And that's been very valuable because the system tests are really slow, so nobody runs them when they're doing development. But on the other hand, if nobody runs them, then when you go to do your release, you're going to find out, oh, well, we changed how this form looks, and now the tests can't find the form fields and scribble them in and actually submit the form anymore, or something along those lines. And that got really tedious when we were doing releases because release management used to destroy somebody's week. And most of that was actually spent just squinting at the test output from the system tests saying, well, it looks like the site actually works, but why is the test broken? Oh, I see, this needs to change by 3 characters. And it was just not practical in the long term. So running your system tests in continuous integration against all of these in-memory implementations makes them run fast enough they can finish in continuous integration, and you find out you broke them in an hour instead of in 5 days.
And so we've changed our design around for testing. We use a framework to inject our object dependencies. We use another framework to create our mock objects. In our constructors, we automatically create our dependencies if they're not passed in. And we twist our code around a little bit to make things work.
No, that's not what we do. We stopped doing all of those things.
We had done those things, and we actually believed that they were virtuous at the time, and we've moved past them much, much happily. We now design for code that we can both test and love. We inject our object dependencies as required construction parameters. So let's take a look at this.
We used to do the top. Right? We used to have these, pass in a database handle, and if you don't pass one in, I'll construct the one that talks to a real database just dynamically from a command line flag. And we thought that was great because it meant that all of your production code required less code. And anytime you need to mock it out, just pass the mock one in. What happens if you do that?
What happens is that you have a production binary reaching out and looking for someone's developer configuration.
Or you have a test reaching out and trying to hit something in production. If you do the bottom, where you always pass in the database explicitly, you can't do that. And it's just been a lot safer and made the tests a lot more reliable that they're actually using fake implementations.
And if you forget something, your code crashes, either in your production or test. Things crash, but they don't behave badly. You've also heard before, probably at some point in your life, separate your state, and especially your storage, from your behavior. This turned out to be surprisingly easy, and I'm going to walk you through why and just an example of that. This is the way we used to have classes, and this is the way our class methods used to look, our instance methods. And it's, it starts off, there's some really good business in the middle, and then it assigns an attribute and doesn't have a return value. So you've probably written methods that look like this. And I want to take away all that business, and let's just look at this. We see the object itself, the instance itself, has an attribute read early in the method, and an attribute assignment as the last part of the method. Everything else does not touch the instance at all. And so we can pull it out. We can take that exact same business and put it in a free function, a pure function that is perfectly testable because it has no state changes, and its return value is solely a function of its inputs. Perfectly testable. This is very easy. And then we go back to our class, and what's left is just that early attribute read and that final attribute assignment. And so when you're thinking this way, when you're starting to refactor your code this way, you can watch your classes shrink before your eyes. And it's wondrous. And I've gone so far on this that I get the heebie-jeebies when I see a class more than 50 lines long. I mean, what could they possibly be doing in there? What could they possibly need to have such close interaction with the object state for? Functional programming has it's won us over in this respect.
And we also have found that it's really valuable to define clear interfaces between your components. Early on, things were kind of a tangle, and request handlers would just open up a reference to the table and write some stuff to persistence, and that was okay. But that makes it both hard to do any kind of refactoring and also really hard to do any testing. Is there any more you wanted to say about that? Sorry.
No. The last point is just don't write a test if you can't figure out how to. If you can't figure out how to write a robust test, if you can't write a test that's not overly coupled to the underlying implementation, take that as a code smell. Take that as an indication of further thought, further attention. Don't write a test that's only going to slow you down when you come back with a better idea of how to do that abstraction.
I've seen tests like this that take it to such an extreme that they use some mocking library to make up an automatic mock of everything. And what it's actually testing at the end is that the compiler works, because the test actually reads like this. You should call this method, then call this other method, then log these two things that you got returned from that, then return one of those things. And that's just not useful, because you've proved that your compiler does what it says on the tin. And if your compiler doesn't work, you really should just give up and go home.
Thank you.
So. We've got a couple of links that might be a little interesting at the bottom of this last slide. Since they're long links, the QR code should take you to the source code for our slides.
Any Q&A, we got a couple of microphones, or if you can just say your question, they'll repeat it so it gets on the video.
Right here in the red hat.
You said don't write tests for things that aren't clearly testable.
Mm-hmm.
I'm coming from a place where we don't have a lot of tests at all, and so we tried to put 100% statement coverage is like we need some lines to put in the sand, and I'm a little concerned that if I say, but if it's hard to test, just don't bother, because then we'll go back to writing hard to test code.
Okay, so the question was about don't write tests for untestable code. He's coming from a place where there's very little test coverage right now, and they want to put a line in the sand for statement coverage. How would you answer that?
Well, any new code, try and design it for testing, obviously. And you try and use, to an extent, do what we did and use system tests to try and make up for some of the gaps in coverage. But at the end of the day, the bad tests where you're using too many mocks actually just cost you time. They made us feel good because we had high relative line coverage. But when the rubber met the road and we tried to deploy these things, often there was no relationship between that little orb being green, or white if you're me, and actually having a working binary when you pushed it to production. False security is really, really bad.
Let's go to the microphone.
I'm trying to resolve your point on dependency injection. So you're talking about live code requiring a database equals none was kind of a problem, or you're talking about the mock object?
I'm sorry, I didn't hear all of that.
When you're talking about dependency injection, you had a database and database equals none as your two examples, and the database equals none was the bad way of doing it.
That's right.
Yeah.
That's not a mock object. That's a live code example, right?
Yes.
Correct.
And does that mean that you don't use defaults anywhere? I feel like that's at odds with having sane defaults.
So sane defaults are a good thing, but sometimes you have these things that just really have to be specified. And so if it's controlling a critical piece of behavior, like where it's going to write its persistent data, we found that it's much safer to make it a required argument and just always specify it.
Yeah. We've found that in cases of object relationship where a first object does not make sense unless it also has a second. So a user profile doesn't make sense unless it has a user credential or something like that. We found that explicit construction parameters is the most robust solution for us.
Then you guys must really hate star args, star quargs.
No, I use them all the time. But those are good for things that are going to change the behavior of your object in a subtle way, right? This is an example because this object just doesn't make any sense if it doesn't have a database, right? You have to have a database. Whereas if it was like a little flag that said, treat the user one way or another, treat all users as admins or some goofy flag like that, maybe that would be different. Or like, does this view require an admin?
Is it safe to say that we're phasing out star and star args for construction parameters?
Yes.
Okay. Yeah, we do use them extensively on methods for behavioral
And we do use them for when we're passing things through to a superclass.
Very interesting talk, thank you. To somebody who asked about adding tests to code that's not tested, I might suggest the book Maintaining Legacy Code. I think that's what it's called, by Michael Feathers. So something to look at. It offers some techniques for doing that. I wonder, when you guys are designing your code for testability, have you found it useful to follow the tell, don't ask principle?
I'm not familiar with that, I'm sorry.
The tell, don't ask principle? Just spell it out for us.
Basically, there's a school of thought that in proper object-oriented design, you wouldn't basically be calling a lot of getters and setters on objects because it's kind of breaking abstraction. And so instead of asking objects what their state is, you should be telling them things to do, basically. So it's kind of a different way of thinking about it.
I think everything we've done has been wholly independent of that. I don't think we've been swayed one way or the other by the directions in which we've taken our code.
It does sound similar to what we already do, but without giving it more thought, I don't know. Sorry.
Sorry. Thank
Okay,
you.
thanks.
Hey, when you mentioned your inspect hack, I immediately thought of something. Do you guys use any kind of strong interface, like ABCs or ZOP interface, when declaring your objects? Especially things like ZOP interface have very quick, very powerful ways to immediately verify whether or not an object holds up to its contract. And I was curious as to whether or not you guys had inspected those before going with a more home-world solution.
No, because at the time that I wrote the horrible inspect hack, we were on 2.4, and so the ABC stuff hadn't been implemented yet, I don't think.
Right.
That's 2.6, yeah. And as far as the ZOP interface stuff, that's a little more heavyweight than I want. Also, a lot of our mocks don't implement everything. They implement enough that whatever things are tested will work.
A lot of our mocks are works in progress with notes that say, hey, I only did as much as I needed for the tests in this moment now. If you need these additional methods, go ahead and flesh them out.
Yeah, and even a note saying who will gladly do the code review if you write it. I always fast track those kind of things when I get them, but it's just not always practical to sit down and write a fully functional in-memory implementation of something when you just need 2 methods so that you can test one little view function.
I see. Thank you.
So we're intentionally cheating with duck typing.
Okay.
Okay, thanks.
So I like what you guys said about having system tests for the user stories. I'm curious whether you think that like the ideal situation is to have everything under unit tests, or whether you think it's actually kind of pick and choose the scenarios where unit tests are better and other scenarios where the system tests are better. Because I think there's a lot of religion around sort of, oh, everything must have a unit test, and that's not always the right answer because sometimes just refactoring your code forces you to change so many unit tests.
Yeah, so the question is basically when do you use unit tests versus system tests? And we do have a decent chunk of code that's not unit tested at all.
Mm-hmm.
The very highest layers that at application startup, go and open a handle to a big table and then glom it into a bunch of other objects. That's not tested because it's not testable. But it's also like 6 lines. And so it's very easy to be comfortable with this is correct by inspection, visual inspection in code review. And if it ever changes, you just do the same thing again.
I would say that my philosophy is that I believe in strong testing of behavioral parts of software. So things like functions, things like computations, things like state changes. And I don't believe in unit tests for assemblies, right? When you're starting up your application, when you're connecting one object to another, or when you're constructing something, what you might think of as glue code, it's simple enough and it's going to be covered by your integration tests.
Like this contemporary class example that we had, right? We might not write a test for that because there's really no interesting logic in there other than the side effect of setting an attribute, but I would question whether you should be doing that anyway.
Yeah. But we've already written the test for the pure function that we've factored out of that method, so there's not a whole lot of incremental benefit to testing this instance method as well.
Cool, thanks.
All right, let's take one more quickly.
Hi, I just wanted to try and understand more clearly what you said earlier about mocks and fakes. It sounded like what you said is that all of the things you've been referring to as mocks are actually fakes. You don't actually use like what are officially called mocks in your testing
that's right.
at all?
Yeah.
Is that true?
So the question is, do we use mostly mocks and not fakes, or exclusively fakes and not mocks? See, I'm already confusing the terms. That's almost true. Every once in a while, and this will happen to you too, right? There'll be like a third-party service that we interact with where you just can't get around the fact that you don't have a fake. And so you have to use a mock in that case. Like you need to verify that like you've hooked everything up correctly. And sometimes a mock is the only way out, but we treat it as a tool of last resort, not something that we go to immediately.
But you never write a mock for something that you wrote.
No.
Okay, I don't know if there's time to explain, but I would really like to understand how you managed to do that, because
Just come up and
Yeah.
continue it with us. Thank you very much, everyone.